Let's remember that our learning targets are to be able to graph absolute value functions without making a table. This is going to serve you well when you get to other function families because there are ways to graph them just by looking at what is happening to them. Let's go back to the parent absolute value function. Do you remember what it looks like? Hopefully. Can you graph the parent absolute value function on a grid? Remember, its vertex is at the origin 0, 0. It rises 1 and runs 1 in the right direction, and it reflects and does the same thing in the left direction. So you end up with the shape that looks like a V. Now we learned this in the previous video. What does this minus 4 do to this parent function that I just drew? Well, hopefully you remember that the minus 4 is going to move the vertex down 4, acting as a y-intercept. Now the width of this red one that I'm drawing is the same as the blue one. Sometimes it's an optical illusion if one looks wider than the other, but if you notice, I did attempt to go up 1 and over 1 on both sides of the red graph. Let's look at this one now. I have x plus 2 and it is inside my absolute value. So remember, that's the funny one. That one will move my blue parent function horizontally to the left 2 because my h value is really a negative 2. You'll get used to that the more you see it. But my vertex of my parent function moved over here. I'm back on the blue one, and now the green is how it shifted left 2. So here I have the 3 examples. The parent function in blue, the shifting down of 4 from the red one, and the green equation told us to go left 2. But what if I was given an equation that looked like the one down here at the bottom, where both things are happening at once? Well, you can graph it all at once just by knowing the characteristics of the equation. We already know the negative 4 shifts it down 4. And we know that the plus 2 moves it left 2. So putting these things together, I need to take my vertex of my parent function, which normally would be right here, and I'm going to do to the vertex what my directions tell me. Move it down 4 and left 2. So I will move this down 4 and left 2, and that is where the graph of this larger equation lies. Notice I did not make any table. I simply start by moving my vertex where it belongs, place its new point according to whatever characteristics of the equation told me, and then draw the rest of my branches on my absolute value function. Let's try it again. Here I have the new absolute value equation, y equals the absolute value of x minus 4 and then plus 2. Can you tell me what this does to my absolute value function? It moves it right 4. And what does this number do to my absolute value function? So, remember, your vertex would have been here, and now your equation is telling you to move your vertex up 2 and right 4, and that is the new location of our absolute value function. The branches will rise 1 and run 1 to the left and to the right. If you don't believe me, feel free to create this table, and you will see that truly that is the graph that comes out. So, looking at the result, I do know for sure that I will have points at 2, 3, 4, 5, and 6. Putting 2 into my original equation, 2 minus 4 gives me 2. It's really a negative 2, but I took the absolute value of it. And 2 plus 2 is 4. Exactly where my absolute value graph is. Putting in a 3. 3 minus 4 is a negative 1. Its absolute value is a positive 1. And 1 plus 2 is 3, right where that point is. Go ahead and finish to prove it to yourself. I'd like you to try these 2 guided practice problems. And again, I really do recommend just writing right below the equation what those values are doing and then translating your vertex the way you need to. Pause the video now. That's what they should look like. We have one more thing to discover about absolute value graphs, a situation that you'll see often. That situation is when you have a negative sign in front of your absolute value. What do you think that is going to do to our absolute value parent function? We will find out with a table, and then we won't need to use a table after this. Putting a negative 2 in for x tells me to take the absolute value of a negative 2. Well, that's a positive 2. Then, after I've done that, this minus sign is still lurking outside, waiting for my result. So my answer will be a negative 2. Putting a negative 1 in for x gives me the absolute value of a negative 1, which is a positive 1, and then that minus symbol outside attaches to it. A 0 just gives me a 0. 1 will result in a negative 1 again, and 2 will result in a negative 2. And when you graph this, maybe this is what you guessed would happen. It has flipped our absolute value over the x-axis. We normally don't say flipped. The word we like to use in math is reflected. So our parent absolute value function was reflected over the x-axis because there was a minus sign in front of it. So now we have another bit of information for how to graph an absolute value equation. Let's write down all the things we know about absolute value equations. I'll give you a hand. What does adding a number to your absolute value do to it? What does subtracting a number from your absolute value do? What if your number is inside the absolute value? And finally, what if there's a negative sign in front of your absolute value? Write the result of each of these situations. You'll never have to make a table again. Pause the video and finish this up. You should have phrases that are similar to these, but more importantly, you should just know what these numbers do. So now we're going to put it all together in one equation with no tables. Here they are. Go through with your arrow and tell me what each of these numbers is going to do to my graph or vertex. What will the negative do? What will this do? And what will that do? When we begin to graph these, we're going to move our horizontal and vertical shifts first. That means we're going to deal with these two things. I know my vertex is left 1 and up 6, so I can do that right away. And I know it's up here. The negative sign out front will create a reflection. So if I didn't have the negative, I would have had my absolute value function looking like that. But because it is negative, it's going to be going down or opening down or reflected. We use all those words. And this is your final graph. Notice I didn't make a table. Let's do the second one. Same idea. What will that do to your graph? What will the 5 do, and what will the negative 2 do? Write those down. Now go ahead and graph it yourself and see if you can do it. Pause the video if you need more time. But I see that this means I move right 5 and down 2. So my new vertex is right here. And it is reflected. And so instead of opening up, my absolute value will open down. Thanks for watching. And as always, if this stuff is super confusing, a second time watching the video might be just what you need.